So this is the last chapter in your book. It is called Radioactivity. So we'll discuss about radioactivity in the chapters, not in the beginning. In the beginning, we'll discuss about how does an atom, how does the atom look, structure of an atom. Structure of an atom. So basically, what happens is atom is a system consisting of two main bodies, right? So there are two bodies in an atom. So first one is the central mass known as the nucleus. So around 95% of the total mass of an atom. So an atom agar 100 gram ko cha hare. For example, it is not possible. If an atom is of 100 gram, 95 gram will be completely situated in the nucleus. So we'll have a big central mass called the nucleus. So this is the nucleus. Then around the nucleus in orbits, we have electron revolving. So for your standard, class 10, we study the electrons revolve around the nucleus in orbits, right? And these constitute only about 5% of the total atomic mass or the total atomic volume, whatever it is. So in an atom, there are two bodies. There are two regions where you can find mass. First one is the nucleus. There is the central mass that has around 95% of the total mass of an atom. And the second one is the electrons that revolve around the nucleus, right? So what the takeaway from this part is, one more thing we need to know about atom, very important thing about an atom is, suppose these are the orbits around which electrons are revolving. Okay, so suppose these are the orbits in which the electrons are revolving, and this is the central nucleus. I'll draw the central nucleus somewhere here. So this is the central nucleus, right? And your bahirako sabai is the point where electrons are revolving, orbits. So this alone is 95% of the mass of the atom. And these electrons constitute only about 5% of the atom. And one more takeaway is, the only thing tangible, or only thing that can move in and out of an atom, that can move out, move in of an atom, are the electrons only. So you can't touch the nucleus. You can't remove a proton from a nucleus and make it go out of the nucleus, or bring a proton and put it inside the nucleus. Okay. So the only thing tangible in an atom will be the electrons. So electrons have ability to go out of the atom, come into the atom. Something like this is possible, right? So when you supply enough energy to the electron may come out of the atom. So these things are basically very common. Like we say, like there is a disease called, there is a thing, abnormality called cancer, right? So there is an abnormality where there is some unwanted tissue growth in our body. So there is some growth of tissues that we do not want in our body. So that is called cancer, right? So why does this cancer happen? So for any abnormality to happen in our body, our DNA must function abnormally, right? If our DNA and the chromosomes are functioning properly, there is no possibility of abnormality in our body. Okay, you should be very clear with it. And our body has a lot of DNA. There's a lot of DNA strands, and for a DNA to be corrupted, it is very extremely rare. Okay, the DNA can corrupt only if there is some drastic changes happening in the body, drastic unwanted things that is happening in our body, right? So these unwanted things that can drastically change the order of a DNA is radiation. Okay, if we are exposed to continuous and harmful radiations for a long period of time, then these radiations have the ability to knock an electron off from a DNA molecule. So we have a DNA, right? We have a DNA strand. So DNA ma ke huncha, there are sugar molecules and they're connected by hydrogen bonding like this. So if you are exposed to very strong radiations, even X-rays, right? For instance, if you are exposed to very strong radiations, those strong radiations, they are called ionizing radiations. Ionizing radiation. So ionizing, it is converting an atom to an ion. So what is an ion? Ion is something that has an excess of electrons or deficiency of electrons. So atom is the one that is neutral. The number of electrons and number of proton is the same. So you have an atom. Now, to get an ion out of an atom, we need one electron or more than one electron, more or less in that atom. And that thing is fulfilled by ionizing radiations like gamma rays, X-rays. So what they do is they can hit a critical point in the DNA. So it can hit one point in the DNA and knock an electron off. So it can completely remove an electron off. So what happened? Everything that was neutral here now has turned ion. That now has turned into an ion, right? And this thing may not corrupt the DNA. Like it may not every time result in the corruption of DNA. This DNA like may recover from it, but it is very rare that it'll corrupt this. But if you have extreme exposure to radiation, there are a lot of radiations that can strike a DNA and knock an electron off, right? A single electron getting knocked off a DNA molecule cannot corrupt it. It may not corrupt it. It's very low. It has very less probability to get corrupted. Now, if you have extreme exposure to radiation, so if you are exposed to X-rays for a very long period of time, the X-rays may strike the DNA atoms and just knock the electron off every time, right? So this may result in the formation of cancer. This may result the DNA to corrupt, right? Now, if the DNA corrupts, if the DNA is corrupting, if it is corrupted, then our whole human body will start developing some abnormality. It may be abnormality in the stomach, abnormality in the brain. So accordingly, we have different types of cancers, right? Brain cancer, throat cancer, stomach cancer, and it is completely random. Okay, it's not that if I expose myself more to X-rays, I'll get stomach cancer. It's not like that. This experiment can be done with humans, and every human is exposed to X-rays, and each human may get different type of cancer, right? The cancer in different locations in their body. So it is not necessary that every person exposed to a certain radiation will get the same type of cancer, same type of abnormality, right? It is completely random. It can cause any type of cancer, right? So that is the reason why we don't expose ourselves to ionizing radiation. Even ultraviolet radiation that comes from the sun is an ionizing radiation. If we are in the region where ozone is depleted and we go outside in the sun and walk there for a longer period of time, we have very high probability of getting skin cancer, right? Why is that? Because the ultraviolet radiation has enough energy to go and knock an electron off from an atom, right? So it can knock an electron off an atom. So if the electron gets knocked, the atom becomes an ion, and now the radiation is ionizing, and that ion can create abnormality in your system, right? So that is the reason why we don't expose ourselves. We don't expose ourselves to ionizing radiations. That is the reason why we have ozone layer to prevent the ultraviolet radiation to come and hit the earth. So if ozone was not there, everyone would have skin cancer. Life would not be possible on earth, right? So that is the reason why. And also X-rays are also very momentary only. Like the X-rays, it just goes for a flash and takes a photo, takes the shadow of your bone, and you're told to come out of the room. So you don't expose yourself to X-rays as well, because X-ray is one of the highest energy radiations. X-ray ko baad euta matrai huncha gamma ray. So gamma ray is the highest energy radiation. Just below gamma ray, we have X-rays. So X-rays are very dangerous if you like exposed to X-rays for a long period of time. That is the reason why I think CAT scan hola. So for CAT scan, you need to sign in hospitals, in big hospitals, you need to sign some agreement while doing CAT scan, because I think CAT scan uses X-rays. Not sure. CAT MRI, the magnetic resonance imaging. Or I think CAT scan uses X-rays. So prolonged exposure to CAT scan may also result to exposure to ionizing radiation. So you should understand what an ionizing radiation is. Okay, so if I tell you about ionizing radiation. So these are the radiations that we should avoid. Okay, these are the radiations that we should avoid, because these radiations have these can knock an electron off your atom. So एउटा atomबाट यिनीहरूले electron knock off गर्न सक्छ. So when the electron is knocked off, it becomes an ion, and that basically can cause corruption in like corrupt your DNA or chromosome or whatever it is, right? And you can develop abnormality. Those abnormality, like a scientific term, I mean, cancer, right? So we avoid this ionizing radiations. So like gamma rays, X-rays, UV rays are like ionizing radiations. Other than this, nothing is ionizing. They just heat your body up. Like, so the so-called creatures of environment, they say that 5G is very dangerous to the environment, right? So these guys do not know physics at all. They are like totally useless people. They don't know physics. Literally, they don't know physics, because 5G radiations, the radiations that come out of of 5G tower do not fall in the spectrum. They never fall in the spectrum. So if it doesn't fall in the spectrum, it is non-dangerous. It will not harm you. The only thing maximum a 5G tower can do is heat you up. That too, if you like wrap your hand around the tower. So that is the only thing that a 5G tower can do. It will not kill birds. It will not kill humans. It will not cause cancer. It will not do anything. These are just useless people who have no idea about physics. Okay, so 5G radiations, 5G tower nikalne radiations hai, these do not fall under these three bands: UV, X-ray, and gamma. These are the extremely powerful ionizing radiations that can cause ionization in your body, can cause cancer, right? But the maximum damage that a 5G can do, not even damage, it can just heat your body up. It will just heat your body. That too, you'll not know it. It is like you're getting heated up by sun every day, but you don't get cancer. So what is the problem with 5G heating you up a little bit? But it will not heat you as well, because the bands that we 5G uses, it's called the nanometer band in US. So these bands do not cause cancer, do not ionize your atom. It doesn't knock an electron off. They do not have enough energy to knock an electron off, right? So what the maximum they can do is heat you up. It's like putting a hand inside the microwave oven. Microwave is also a radiation, right? Microwaves money or a radiation, but they do not harm you. You put your food inside a microwave and eat it. So what is the problem? That there is no problem in putting food inside the microwave oven and heating and eating it. So there'll not be any problem using 5G. So if from today, if you hear people telling that 5G is very dangerous, 5G can cause cancer and all those things, just explain this. 5G radiations are non-ionizing. They do not ionize your body. They just maximum to maximum they can do is heat you up. That too will be very, very small. You'll not even know that your body is getting heated. Your sun, if you stay outside the sun, you get heated. You know that your body is getting heated, but you don't react saying that sun causes cancer and all this thing. But just 5G niskine bitike, there were people shouting at like 5G like cancer, but it is not. So if from today, if anyone tells you that 5G causes cancer, no, it does not. Okay, 5G radiations do not fall under this band, which causes ionization. Okay, so this is the thing. So what was I telling you? I was telling about atoms. We have nucleus. Nucleus contains neutrons and protons, and outside contains electrons. So neutrons are basically neutral. They do not have any charge. And protons are basically positive, and electrons are negative. So there are two terms you need to know. A is known as the mass number of an atom, mass number, and Z is known as the atomic number. So Z is the number of Z is the number of protons in the nucleus. A is the number of nucleons. A is the atomic number one. A mass number one. It's a number of nucleons, which means number of protons plus number of neutrons. So to find the number of neutrons, you just need to subtract A with Z. So you get number of neutrons. Okay, I'll write this clearly. So Z is called the atomic number. It is basically the number of protons. And A is known as the mass number. It is the number of nucleons. Number of nucleons basically means number of protons plus number of neutrons. So now if you want to find the number of neutrons, it will be at a mass number minus the atomic number. So you get the number of neutrons. Number of neutrons is mass number minus atomic number. And in a neutral atom, so what is a neutral atom? Neutral atom is the atom that does not have extra positive or extra negative charge. So in an atom, the non-tangible part, the non-removable part, the one that cannot be removed of an atom whatsoever is the nucleus and the protons and the neutrons. You cannot touch the protons and the neutrons. Whatever the amount of energy you supply, the nucleus cannot be changed of an atom. There are some ways you can alter it. You can add it. You can do some alterations, but that'll come later in the chapter. But any amount of energy supplied to an atom will not affect the nucleus. Nucleus will not be affected, right? So I cannot change the number of protons in an atom. So it is not possible to change the number of protons in an atom. So number of protons will remain the same in an atom. So for example, if an atom has 14 protons, then to make it neutral, it needs to have 14 electrons, right? Because proton is positive, electron is equally negative. So the charge of protons and electrons are same. 1.6 into 10 to the power minus 19 coulomb is the charge on an electron. It is negative. So charge on a proton is positive 1.6 into 10 to the power minus 19 coulomb. So they are exactly the same particles, but one is positive, one is negative. They have the same charge, right? So if you have 14 protons in the nucleus of an atom, to make it neutral, you need to have 14 electrons revolving around the nucleus, right? So for a neutral atom, atomic number Z is equal to the number of electrons as well. This is only for neutral atom, okay? अगर एउटा atom neutral छ भने उसको atomic number, that is number of protons, will be equal to number of electrons. So for a neutral atom, the atomic number is also the number of electrons. It is only and only for a neutral atom. If it is ionized, if it is an ion, then this statement will not be valid. For a neutral atom, the atomic number will be equal to the number of electrons as well. Not only the number of protons, but also the number of electrons. Okay, so you should be very clear with this. So Z भनेको atomic number भनेको number of protons in the nucleus of an atom. Then A भनेको mass number भनेको total number of nucleons, which means the addition of protons and neutrons in an atom, right? So this is an important thing in this chapter which you need to know. So that only tangible part, the only part that can be touched or not touched, only part that can be removed or added in an atom are the electrons. Electrons are the only ones that can move in and out of an atom. The protons and the nucleus is like it will not move, it cannot move, right? So electrons can only move when you supply energy, right? When you supply energy, an electron can go out. When that electron loses that energy, it will come back. So what is the answer? So electron is the only thing that is moving in and out of an atom. So you should, your statement पनि clear हुनुपर्छ कि for a neutral atom, the atomic number will be equal to the number of electrons. किनभने for a neutral atom, the number of protons will be equal to number of electrons. So since atomic number is the number of protons, for a neutral atom, that will be equal to the number of electrons. Okay, so this part is done. So there are few technical terms you need to know now. Isotopes. So isotopes, now we have the definition is atoms of the same element. They are of the same element. Atoms of same element having the same atomic number, but different mass number. Different mass number. So they're like what do you say, atoms, they are of the same atoms. So for example, carbon ko isotope, carbon has 3 isotopes, okay? It is called C12, C13, C14. So all of these have the same atomic number, which means they have the same number of proton and electron. So there are 6 protons, 6 electrons. Your case they have 6 protons, 6 electrons. They have 6 protons, 6 electrons. So the only thing that is changing here is the neutron. So this has 6 neutrons, this has 7 neutrons, this has 8 neutrons, right? So these are the isotopes of carbon. So isotopes भनेको चाहिँ atoms of the same element, C, they are same element, they are carbon, which have the same atomic number. So they have the same atomic number 6, same number of protons and electrons, but different mass number 12, 13, 14, which means they have different number of neutrons. Neutron number is different. Their proton and electron number is same because it is neutral. So I don't write I don't write minus C612. I don't write this way because I don't need to write this minus because it is neutral. The number of proton and the number of electron will be the same. So I just write 6C, 6C12, 6C13, 6C14. So I don't put a sign in front of carbon saying that it's positive or negative because it is neutral. The number of electrons and number of proton is the same. But the only thing that is being added here is an extra neutron every time. So 6 taken 7, 7 taken 8. So these are the isotopes of carbon. So there are isotopes of hydrogen as well. 1H1, 1H2, 1H3. यसलाई प्रोटियम भन्छ, यसलाई deuterium भन्छ, deuterium, and this is called tritium. These are the isotopes of carbon. So isotopes of hydrogen, sorry. This has 1 electron, 1 proton, and 1 neutron, first group. This has 1 electron, 1 proton, 2 neutrons. Right? No, sorry, my bad. So यसमा के हुन्छ? यसमा एउटा electron, एउटा proton, there is no neutron because one atomic number 1 भनेको चाहिँ it has 1 proton, and also since it is neutral, मैले यसको अगाडि चार्ज लगाएको छुइन, it also has 1 electron, and mass number पनि 1 छ भन्दैछ. Mass number भनेको के हो? Number of proton plus number of neutron is equal to the mass number A. So यो माथिको चाहिँ mass number हो, यो चाहिँ atomic number हो. Okay, so mass number is proton plus neutron. So now we know that mass number is 1 and number of proton is also 1. So number of neutron is 0. So 1 electron, 1 proton, 0 neutron. So this has 1 electron, 1 proton for sure, and 1 neutron, because यहाँ अब हामीलाई थाहा छ कि atomic number is 2, I mean mass number is 2. We know the number of proton is always 1. So number of neutron has to be 1. So number of neutron is 1. So for this, we have 1 electron, 1 proton, 2 neutrons, because now the mass number is 3 for sure. The proton the same, 1. So neutron has to be 2. So 1 electron, 1 proton, 0 neutron like protium. 1 electron, 1 proton, 1 neutron like deuterium. 1 electron, 1 proton, 2 neutron like tritium. Okay. So isotopes, they are of the same element. This is atoms of the same element that have the same atomic number. They have the same atomic number, 1, 6, 6, 6. Different mass number. So their mass number is different, 12, 13, 14, 1, 2, 3. So the only thing different in isotopes is the number of neutrons. So different isotopes of the same element will have different number of neutrons, right? So this way in your book, there are 2 more examples given. Hydrogen, I did hydrogen, I did carbon. Now you have chlorine left. Chlorine is given in the book, so I want you to read it by yourself. Very simple. So if you have any doubts regarding this, please let me know right away. I'll do one more topic after this if you don't have any doubts. So if you have any doubts regarding isotopes, let me know right now. You can type it in the chat, or you can just unmute yourself and let me know. Isotopes are atoms of the same element that have the same atomic number but different mass number. Okay, so if you don't have any doubts, I'll continue with the next topic. Next topic is isobars. Not the geography wala, the physics wala. So यहाँ चाहिँ के हुन्छ भने different element. That have same mass number but different atomic number. So these are atoms of different elements that have the same mass number but different atomic number. So we have example 11Na23. Yeah, 11Na23 and 12 Mg23. So these have different number of protons. This has 11 protons, 11 electrons, 12 neutrons. So why 12 neutron? Because we have 23 as the mass number. So mass number is number of proton plus number of neutron. So we know the number of proton is 11 plus neutron. So neutron will be equal to 23 minus 11, that will be 12. So 12 neutrons. So yeah, 12 proton, 12 proton, 12 electron, 11 neutron. Why 11 neutron? Because we already know it's 23. We know the number of proton is 12. We don't know the number of neutron. It will be equal to 11. 23 minus 12 is 11. Okay. So isobars are atoms of different elements, that have the same mass number, that have exactly the same mass number, because they have the same mass number, and different atomic numbers. They have different atomic numbers. Sodium has 11, magnesium has 12, right? So atoms of different elements that have the same mass number but different atomic number. So that is another example of carbon and nitrogen, 6C14 and 7N14. So मैले previous example मा carbon को isotope देखाएको थिएँ. There is 6C14. This is the 14 वाला isotope. I think this one is used for carbon dating. So if you have heard about carbon dating, either of these two, any one of these is used for carbon dating. I forgot which one. I'm not sure about it. I think this one is used as carbon dating and this one is radioactive. I don't know. But one of these is used in carbon dating. So carbon dating भनेको के थियो? Carbon dating is like that. यस्तो हुन्छ नि, archaeologists they discover some bones and all those things, and they can accurately predict it from which era, on which year, how many years ago was that bone present on Earth, right? So how do they know that so accurately? So that is done by carbon dating technology. So one of the isotopes of carbon is used in that technology, where we use that isotope to find the age of some prehistoric, whatever we find, fossils and all those things. So that is used for finding the age of those prehistoric archaeological excavate, whatever is excavated, right? So one of the isotope of carbon is used in that process, carbon dating. Okay, so त्यो पुरानो पुरानो सामानहरु खोजेको exact date कहिले निस्केको थियो, कहिले बनिएको थियो, कहिले थियो भनेर चाहिँ we can know that, right? So that technology uses one of these isotopes of carbon. त्यसलाई चाहिँ carbon dating भन्छ. Okay, so so there are two elements given here, carbon 6C14, and there is nitrogen. So normal occurrences 7 and 14. No? So these have, this has 6 protons, 6 electrons. So how many neutrons? 6 plus 6, 12. So 8 neutrons. 6 plus 8, 14. So this has 7 protons, 7 electrons, 7 neutrons, because 7 plus 7, 14. So now they have different number of proton, different number of electron, different number of neutron, but they have the same mass number. They have the same mass number, and different atomic number. So these are isobars. Isobars. So isobars भनेको atoms of different element that have the same mass number but different atomic number. They have the same mass number but different atomic numbers. Okay, so these are known as isobars. So these are all like
isobars similar property हुँदैन? Isobars like similar हुँदैन?
No,
means
nothing is similar. Only the mass number is similar. Combined mass is similar. Okay, so you can't say that they have similar properties. You can't say that. They'll not have anything similar. I think they'll not have any similar, because they'll not have anything that is exactly the same, right? There are 11 protons. This has 12 protons. This has 12 neutrons. This has 11 neutrons, 11 electrons, 12 electrons. So they might be very close. That is the reason why they are placed very close in the periodic table. So carbon and nitrogen, they are just one element apart. Carbon is here, nitrogen is here, right? These are just side by side. So there might be some characteristics that may be common to them, but it's not exclusively written somewhere that they have properties in common. They share, isobars share common properties. It's not given exclusively anywhere, right? So you can say that isobars have they share similar properties. They do not. If they did, it would have been written exclusively somewhere. It would have been like mentioned somewhere exclusively, but it is not there, right? So so radioactivity. So what we know like after all these things, while you sub introduction take so that tomorrow I can start a new topic, and that topic will be radioactivity. So radioactivity, we are trying to break an atom into like smaller parts, right, by the spontaneous emission of radiation. So if we can disintegrate something, so I'll give you a brief, like, only get the introduction to that radioactivity. Okay, so radioactivity is we are getting like radiation or energy output, radiation, by messing up with the structure of an atom, by disintegrating an atom, disintegrating an element or whatever it is, right? So we know that E equal to mc square. So this is one of the most famous equations by Einstein, which is a mass energy conversion equation, where it states that energy can be readily converted into mass and mass can be readily converted into energy. So we will use this equation to study radioactivity. Not exclusively, will not go around this equation, but there'll be a part in this chapter where I'll explain this equation and explain you radioactivity with respect to it. Okay, so radioactivity is we are like getting radiation output or energy output, spontaneous radiation output when we mess with the atoms or element structure. So when we disintegrate an element, sorry. So when we disintegrate an element or an atom, we have spontaneous emission of radiation or energy. So that phenomenon is known as radioactivity. You don't need to write anything right now. So I'll explain to you this topic tomorrow. So tomorrow will be completely about radioactivity and particles that what is this topic? Wait. So tomorrow will be radioactivity and radioactivity as emission of alpha, beta, and gamma radiations. So these two topics we'll be doing tomorrow. So as so if you have any doubts, you can just let me know right now.